This is Unit 2, Lesson 6, Part 2, where we do the application. So the story problems where we're piecing together our own equations and then solving them using the methods that we were just talking about. So I find with the story problems, the most challenging part for most people is the actual setting up of the equations. So we're not going to solve all of these, but we are going to set up all the equations just so you can see how the words would translate into equations and what the variables would look like and different things like that. So we have the same steps that we had a couple lessons ago when we just had two variables and two equations. You still want to identify your variables, and if you choose X, Y, and Z every time, that's fine. Just make sure you identify what's what, or if you want to use letters that kind of make more sense for whatever quantity you're talking about, that works as well. So for number 6, it says the theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9, so these are his number and his price. Sarah bought, this many of each and her price. Kyle, same situation. Find the cost of each type of ticket. So make sure you know what it is that you're solving for and make sure that you're clear about that when you set up your variables. So we have general admission, so we're gonna write G is equal to the cost of a general admission ticket. Senior citizen, let's use S. That is the cost of a senior citizen ticket. And then we'll use C for child. Okay, so we set those up, kind of keep those in the background. Those are going to be the variables that we're using as we work through this whole problem. So let me separate this out. So now we can set up equations. So we're going to set up an equation for Mark. So Mark bought 9 general admission tickets, 2 senior citizen tickets, and 3 child tickets, and paid $170. So this is an equation that represents the total price that Mark paid. So if he's got 9 per ticket, that's going to be 9 tickets times whatever the tickets cost. And then you add that to 2S, which would be 2 tickets times however much the tickets cost. So like say they cost, I don't know, $8. 2 times 8 would be $16 that he spent just on the senior citizen tickets. And then 3, so 3 tickets times whatever the children's tickets cost, same sort of thing. Add those all together, he paid $170. So we can do the same thing for Sarah and for Kyle. So Sarah bought 5 general admission tickets and 4 senior citizen tickets and 7 child tickets. She paid $173. And then Kyle bought 4 general admission, 1 senior citizen, and 6 child tickets, and he paid $116.50. So it looks like one of them must be not a whole dollar amount because you end up with 50 cents. I would guess that it's the senior citizen because he only bought one of those and he ended up with change of 50 cents. So this is our 3 variable, 3 equation system. We're going to solve it the exact same way we did in our last lesson. So the first thing we're going to do is look for a variable that is easy to eliminate. And my eye goes right to this, 1s, because that is just a blank slate. You can multiply it by absolutely anything you want so that you can get everything to cancel out. So first let's get this 1s to cancel with this 2s. So I'm going to turn this into a negative 2s so that those things will cancel. So I am going to line up Mark's equation. And then I'm going to take Kyle's equation and multiply everything by a negative 2. Okay, so I'm just going to write that I'm taking a negative 2 and multiplying it by Kyle's equation. So that's what I'm going to write right here. So in case you're wondering like where these new numbers are coming from. So 4g times negative 2, 1s times negative 2, 6c times negative 2, and then 116.50, I'm going to use my calculator for that one, times negative 2 is negative 233. Okay, so I wrote this down just to remind you that this is Kyle's equation. So this is Mark's equation, Sarah's equation, Kyle's equation. This is just Kyle's equation times a negative 2, just so you know where those numbers came from. So add up everything together. This gives me just a 1g. These eliminate. Minus 9c is equal to negative 63. So that's our new equation, and remember what we did in the last lesson is we would call this one A. Okay, so now let's keep everything all nice and organized here. So now we need to do another combination. So let's look back up at our original equations here. Remember, you have to use the equation that you haven't used yet. So we already used Mark's, we already used Kyle's. That means we've got to use Sarah's. So we're going to use Sarah's equation, and you have to eliminate the variable that you already eliminated. So we have to use Sarah's equation, and we have to eliminate the s's again. So if you look between 4 and 2, that's fairly easy to work with. If you look between 4 and 1, that's fairly easy to work with. I know I normally choose the smaller numbers, but I'm actually going to go with 4 and 2, because this one I would multiply by a -2. This one I would have to multiply by a -4. So all my numbers would actually stay smaller if I chose to use Mark's equation. So I'm going to take Sarah's equation. So let me actually write. So just to remind you up here, this was Mark's equation. So I'm going to take Sarah's equation, which is the one I haven't used yet. And then to get the 4s to eliminate, I'm going to turn this into a -4s. So I am going to take Mark's equation and multiply it by a -2. Remember, another option is you could take Kyle's and multiply it by a -4. So multiplying all of this by a -2. So that'll be a -18g, -4s, -6c, and this would be -340. So all of Mark's equation multiplied by a -2 so that I can get the s's to eliminate. So these, when I add everything together, I get a -13g. These will eliminate. Plus c, which is so nice that that's just kind of a blank variable because I can do anything I need with that in the next step. And then 173 minus 340, that is -167. And just like the last lesson, we're just going to call that b so that we can easily combine it up with something else in the next round. Okay, so that's where we're at so far. Now we have two equations that have two variables and we're going to solve. So I have a blank variable here and a blank variable here, both fairly easy to work with. I could turn this into a 13g by multiplying everything by 13. I could turn this into a positive 9c by multiplying everything by 9. I'm just going to stick with the smaller one. So I am going to take equation A exactly the way it is. And then I'm going to take equation B and multiply it by a 9, because that'll turn this into a 9c, which will cancel here. So I'm going to take equation B and multiply it by a 9. So this, -13 times 9, is -117, plus 9c is equal to, and -167 times 9, big numbers, -1503. Okay, so line these up. Oh, I'm sorry, this is a -117g. Almost missed that. So combine these up, this will be a -116g. These will eliminate, equals -1566. So I am finally just about to find out my first one. I can figure out what g is. Just divide both sides by -116. And that gives me 13.5, and since we're talking about money, that means that's $13.50. So I found one of them. General admission ticket is $13.50. So that's a good start. I can use that to find C, because both of these equations have a G and a C. I'm going to go with this one because the C is by itself here. So next, I'm going to solve for C. So -13g, that's where the 1350 gets plugged in, plus c, so I can solve for that, is equal to -167, and then solve for c. So multiply this. This is -175.5 plus c is equal to -167, and then to get c by itself, just add this to the -167. So -167 plus 175.5. And that gives me 8.5. So 8.5, remember, because it's money, we're going to write it as $8.50. So that is the price of our child's ticket. So we've got 2 out of the 3. So the only other thing we need to figure out is the price of the senior citizen ticket, which now that we know these two, we're just going to sub them into one of these equations. And I would go with Kyle's equation because the S is already by itself here. So let's work through that. So 4G, plug in 1350, plus S, which is what we're trying to solve for, plus 6C, that's 850. We know that comes out equal to 116.50. So let's multiply these numbers together. 4 times 13.5 is $54. So Kyle spent $54 on general admission tickets and 1 senior citizen ticket. Then 6 times $850. 6 times, sorry, I did plus. 51, spent $51 on children's tickets. Came out to equal $116.50. Add the 54 and the 51 together, we get 105. So this tells us kind of the leftover cost that must have been the senior citizen ticket. And subtract 105 from both sides. That gives us 11.5. So again, it's money, so that means that the cost was $11.50. So that is the price of the senior citizen ticket. And remember, with application problems, we don't really do ordered pairs because there's no specific order that they're supposed to be in. So we can just leave it like that. All right, next one, number 7, we are just gonna set up the equation and then we're gonna stop. So Jamie has a collection of 78 nickels, dimes, and quarters worth $12.40. If the number of quarters is doubled, the value becomes $22.15. How many of each type does Jamie have? So the how many is what we're trying to solve for. So N is how many nickels. D is how many dimes. Q is how many quarters. So I'm going to just walk you through how to translate words into equations. So she has 78 of them altogether. That means the number of nickels plus the number of dimes plus the number of quarters is 78. That's like a quantity equation. The next one has to do with the money, and so then you bring in how much each one is worth. So each nickel is worth 5 cents. So 5 cents times the number of nickels plus 10 cents times the number of dimes plus 25 cents times the number of quarters comes out to be $12.40. There's a second equation that's got to do with the money, the total amount. And then we have this second sentence. So if the number of quarters is doubled, the value becomes $22.15. Okay, so we are doubling the number of quarters and that changes the value. So all of these stay the same. So now we're saying that she's got twice the number of quarters and the value becomes $22.15. So that's how you'd set up that third equation. So then you'd solve it in a very similar method to what we just did with number 6. So I just wanted to show you how to set those up. Let's look on the next page where it says substitution may be a better method. We're going to set up some equations here. So number 8 says Mason has a collection of 49-cent, 20-cent, and 3-cent stamps worth $23.55. He has 56 total 49-cent and 20-cent stamps, and the number of 3-cent stamps is 9 more than the number of 20-cent stamps. How many of each does he have? So we're going to do, let's just go A, B, and C because they're all stamps. So how many? So for A, let's do the number of 49-cent stamps. B will be the number of 20-cent stamps. And C will be the number of 3-cent stamps. Okay, so these are all stamps. All right, so those are our variables. We'll use those variables to set up an equation. So he has a total collection worth $23.55. So 49 cents times the total number plus 20 cents times that total number plus 3 cents times that total number comes out to be $23.55. Next, it says he has 56 total 49-cent and 20-cent stamps. So just the 49-cent and the 20-cent stamps, when you combine those, there are 56 of them. So that equation mentions nothing about the 3-cent stamps. Then this part says the number of 3-cent stamps, so that's C, is 9 more than the number of 20-cent stamps. So that is why this says substitution might be a better method, because you can like solve for C, you could solve for A or B and sub everything back into that equation. So I just wanted to get that one set up, and then number 9, we'll walk through that. So number 9 talks about the medals earned in the Olympics, gold, silver, and bronze. 2014 Winter Olympics, United States had 28 total medal winners, 2 more golds than silvers. The number of bronze was 4 less than the number of gold and silver medals. How many winners were there of each type of medal? So we're going to set up number of gold, silver, and bronze. Okay, so those are our variables. Now let's set up the equations. So first of all, it said the US had 28 total. So add them all together. It's 28. Next statement said there were 2 more gold medals than silver medals. So the gold is the number of silver medals plus 2, because there are 2 more gold and silver. So if silver was 8, then gold would be 10. And the number of bronze medals was 4 less than the sum of gold and silver. So gold and silver combined, and then 4 less than that. All right, so we've got this set up here, and this is just basically telling us how we can sub things in and solve for different variables. So what I want to do is I am going to take this expression and sub it in for G right here, and then I want to take this expression and sub it in for B right here. So we're going to do a little substitution. All right, so let me show you what that substitution looks like. So G, I'm going to replace with S plus 2. So S plus 2, and then keep going here, plus S plus B, so B is this, G plus S minus 4, equals 28. So I took the top equation, but I'm replacing the G and the B with these expressions right here. So now if we look at it, combine everything up, I have SSS is 3S plus G, and then 2 minus 4, negative 2, equals 28. So that's a good start. But what I want to do now is I can actually replace this G again. So since G equals S plus 2, I'm going to replace this G with an S plus 2. So I have 3S plus S plus 2 minus 2 is equal to 28. All right, so now combine everything up. I have 4S. These actually just go to 0. Plus 2 minus 2 is equal to 28. So now I have S, and as soon as I have S, it's going to be pretty quick to find the other ones. So divide both sides by 4, and that tells me that I have 7 silver medals. Then this expression right here tells me that I have 2 more gold than silver. So if I have 7 silver, that means I have 9 gold. And then you can use either the top or bottom equation to solve for bronze. Bronze says it's the sum of gold and silver minus 4. So the sum of gold and silver, you add these together, you get 16, and then 4 less than that would be 12. And we can also just confirm that that all adds up to 28, which it does. 7 plus 9 is 16, plus 12 is 28. So that one went a little bit faster with the substitution trick.